Alright, so this is Unit 5 test review. Let's get working. So the first one, we have like bases. Like bases with multiplication. We add exponents. So this is going to be 6a. Starts in parentheses, keep it in parentheses. The 6a is the base of the exponents, so keep that in mind. Adding the exponents, we have 6a 7/4 plus 5, or 7/5 plus 4/5 is 11/5. And now let's change this into, most of us are going to change it into radical form. The denominator is your radical, so it's a fifth root, and 6a is raised to the 11th power. Now we need to simplify this. So to simplify it, you could do 6 to the 11th, and that's a gigantic number. You could break it down with the trees. Probably going to fill up a whole page. And then 8 to the 11th also. Or you could think of it as 6a, that there's 11 6a's multiplied together. So that's your trees right there. So if there's 11 6a's multiplied together, that means then we need groups of 5. That means we can get 2 groups of 5 out. So 6a times 6a, or you could do 6a squared. And it's still a fifth root. And there'll be, when we take out 2 groups of 5, there'll be 1 group left over. You could do it to the first power if you'd like. Carrying this over, 6a times 6a is 36a squared, fifth root of 6a. We can keep in parentheses if you'd like, or take them out because it's not raised to any power but 1, so you don't have to have it in parentheses just as long as the 6a is underneath the radical. Alright, number 2. We have like bases again, but now it's division. So we subtract the exponents. So we just take, there's a couple different ways you can do this. I just take the numerator, subtract the denominator's exponent, and that's 3 to the negative 2/4. And carrying that over, anytime you have a negative exponent, drop the base of the exponent and the exponent to the denominator, or it starts in the numerator, so we're going to drop it to the denominator, become positive 2/4. That's the same thing as 1/2, so I'll just convert 2/4 to 1/2. And if you need to convert this to radical form, it's a square root because of the denominator 2, and it's 3 to the first power. And that'll be the final answer. On number 3, right, there's 2 different ones. We have the first one, 4 times x to the 2/8. You can reduce 2/8 if you'd like to 1/4, and only the x is the base of the exponent. It's 4 times. If you were to do order of operations, you'd do a number in for x, substitute a number in for x, it'd be to the 1/4, x to the 1/4, 10 times 4. So the 4 has nothing to do with the exponent of 1/4. So when we're converting these, only the x is inside the radical. The 4 is on the outside times. Where on the second part of number 4, the 4 and the x are the base of the exponent. And we can again simplify to 1/4 if you'd like. And if you did order of operations here, it'd be x times 4 first, raise it to the 1/4. So the 4 is included with the base. Converting it, the denominator becomes your radical, so it's a fourth root of 4x. Put it in parentheses if you like. If you keep it in parentheses, it'll always be right. You can write it to the first power if you like. You don't have to. Up to you. Alright, number 4. I see a negative exponent. It's in the numerator right now, so let's drop all the base and the exponent to the denominator. There's a 1 in the numerator, so we have 1 over 16 x to the 8th y to the negative 12th. And I know some of you are probably saying, well, you have a negative 12. That negative 12, that exponent is within this parentheses. We can't move it yet. Once the parentheses are gone, then we can move that negative. So let's convert. You don't have to, but a lot of us like to work in radical form. Much easier to think about. So we have a 4 through to 16. You can break 16 down. 2 and 2, 2 and 2, and a fourth root, so all 4 2's are going to get used up. So a fourth root of 16 is 2. A fourth root of x to the 8th, there's 2 groups of 8. And a fourth root, groups of 4 out of 12 is 3. And then the last part, we're going to move that negative exponent with the base of that exponent up to the numerator. So it's y to the third over 2x squared. And there's your final answer. Number 5, we have to simplify completely. So 81 is 9 and 9. Simplify the square root. So we have 3 left over. The group of 3 that comes out, 3 times 3 times 3 is 27. Cube root of 27 is 3. And there's a 3 left over. X to the 8th, cube root of x to the 8th, there's 2 groups of 3 that I can make out of that. We're given us with 2 left over. Y to the 10th, there's 3 groups, so y to the 3rd, leaving us with 1y left over. On number 6, we have parentheses. We have to simplify here. So we have multiplication first, so we'll multiply 4 times the square root of 10 minus square root of 10 times the square root of 300, or 330 is 300. 300 breaks down. So after you multiply, you always look to simplify. We can keep breaking this down, but we have a pair of 10s. So that's going to be 4 square root of 10. That's going to come down. Square root of 300 is 10 square root of 3 minus 2 square root of 3. 10 didn't break down, it's just 5 and 2. So there's no pairs. It's a square root. We have like terms now. Negative 10 square roots of 3 minus 2 square roots of 3. That is negative 12 square root of 3. Looking at number 7. 2 fourth root, so we multiply. 32 times 8 is 256. W, like bases with multiplication, you add exponents. And the fourth root of 256 is, so to save a little time, it's 4 times 4 times 4 times 4. So there's a group of 4 there. So the 2 stays out, multiplied by the 4 here. And it's w to the 8th. How many groups of 4 can you make out of 8? 2. So it's 8w squared, which is not one of the answer choices. It should be, but it's not one of the answer choices down here. So 8w squared is what you should get. Moving on. Find the perimeter of the triangle. Write your answer in the simplest form. Perimeter means you're adding up all the sides. So let's start adding them up. 3, I'm just going to write it horizontally so it's a little easier to look at. Cube root of 24 plus 8 fourth root of 5. So there's no like terms right now. Like terms meaning like they have the same radical and what's underneath and any variables, but there's no variables in this case. So now I look to simplify. 8 is 2 times 2 times 2, 10 is 2 times 5, and we have a fourth root, so groups of 4, so 3 times 4, fourth root of 5, plus 24 is 8 and 3. 8 is going to be 2 times 2 times 2. It's a cube root, so 2 comes out. And plus 8 fourth root of 5. So it looks like we have a 12 fourth root of 5 plus 2 cube root of 3 plus 8 times fourth root of 5. So we have like terms still. So 12 plus 8 is 20 fourth root of 5 plus 2 cube root of 3. There's your final answer. Sorry, that was a little off screen. Next we have side length of a square is, so we have square. Each side is 4 square root of 2 plus 3 square root of 5. So this is 4 square root of 2 plus 3 square root of 5. Find the area. Area is length times width. So we have to multiply these together. 4 square root of 5 plus 3 square root of 5. And we have to multiply it times itself, since it's a square. Multiplying it out, sometimes I kind of circle, box in, the different terms, so it's a little easier to keep track of. So 4 square root of 2 times 4 square root of 2 is multiply the outsides, the coefficients, multiply the insides of the radicals. And 4 times 3 is 12, 2 times 5 is 10. Multiply then the first two terms, or middle terms here. So we have 12 square root of 10 again, and 9 square root of 25. Doing this, now you look to simplify and gather like terms. So 16 times 2 is 32. 12 square root of 10 plus 12 square root of 10 is 24 square root of 10. 9 times 5 is 45. And we still have like terms here. 32 plus 45 is 77. Plus 24 square root of 10. Square root of 10 doesn't simplify down, it's 2 and 5. Alright, moving on. We have 4 square root of 8, so we're going to multiply this out. 4 square root of 8 times square root of 8 is 4 square root of 64. 4 square root of 8 minus, or times negative 6 is a negative 24 square root of 8. Negative 1 times square root of 8 is a negative 1 square root of 8. And a negative 1 times a negative 6 is a positive 6. So simplifying the radicals, or looking, and also looking for like terms. The middle two terms are like terms, so that's a negative 25 square root of 8. You have a negative 24 square root of 8, that's how many you have, and you're subtracting one more square root of 8, that's a negative 25 square root of 8. We can simplify the square root of 8, simplify it enough to know that it's 3 2's. 2 is going to come out, so we're going to multiply times the negative 25. We also have these like terms here, so let's put those together right away. So that's 38. 2 times 25 is 50. Square root of 2. This should be a minus here. That's your final answer. Down here, haven't talked much about square roots over when it's written over a whole fraction, but square roots you can divide them up, the numerator and denominator. It's a square root. We cannot have a square root in a denominator or a radical in the denominator. It's an irrational number, square root of 10. You need to rationalize it. In order to rationalize it, a square root, you need to multiply by itself. Because when you multiply by itself, you multiply the denominator, you're going to end up with square root of 100. 10 times 10. And the square root of 100 is 10. That's a rational number. Let's multiply out the numerator. So we have square root of 5x times the square root of 10, the square root of 50x. And simplifying square root of 50x, 5, 10, 5, 2. So it looks like our pair of 5's there. So a 5 is going to come out, square root of 2x. And it looks like we can simplify. 5 tenths reduces down to 1/2. 1 times 2x is just square root of 2x, or square root of 2x, that is. And over 2. Simplified. And the denominator is still rational, so that's good. Now cube roots. Cube roots we need to multiply by 2 more cube roots of the exact same denominator. What that does is if you look at the denominator, we multiply cube root of 5x squared times the cube root of 5x squared times the cube root of 5x squared. That's going to be a cube root of 125x to the 6th in the denominator, which simplifies down to 5x squared. So that's a rational number. 5 is a rational number, and we're going to assume that whatever x is in the denominator is going to be a rational number also. So if we're multiplying the denominator by cube root of 5x squared, we also have to multiply the numerator by cube root of 5x squared, because everything we're multiplying here is equivalent to 1. So we're not changing the value of the original expression. We're just morphing it so then the denominator has a rational number in it. So let's multiply this out. We have 2 times 1 times 1 as the coefficients, and inside we have 5x times 5x squared times 5x squared. That's a cube root, let's do this up here, cube root of 125x to the fifth, adding exponents with like bases. Cube root of 125 is, let me rewrite this, 2 times the cube root of 125 is 5. Cube root of x to the fifth is x, with a cube root left of x squared. So let's finish this up a little bit. 10x cube root of x squared over 5x squared. Now we can look, we have our coefficients out front. We have 10 fifths reduces down to 2 over 1 is x. So we have 2, gathering what we have left after simplifying. 2 times the cube root of x squared over 1 times x is just x. And there's your final answer. Moving on. Alright, still simplifying. We have a monomial in the denominator. It's a square root, so just multiply by 1 more. Here we have a binomial in the numerator, so we're going to distribute. So we have cube root of 9 minus cube root of 3 over cube root of 9. Simplifying everything that I can see, any of the radicals. Cube root or square root of 9, I might have said cube root. Square root of 9 is 3 minus square root of 3 over 3. Now we can't really simplify these 3's because the coefficient of the second term in the numerator is 1. 1 doesn't simplify with 3. So I will just leave it like this. The main goal is the denominator is a rational number. Now, number 14, we have a binomial denominator. With a binomial denominator, you multiply by the denominator, but switch the sign. So we're switching from subtraction to addition, and still you're multiplying by something that's equivalent to 1. Now we just have to be careful because we're dealing with a lot of binomials, and when you do binomials times binomials, you have to FOIL or double distribute. So 4 times 2 is 8. 2 times the square root of 5 is square root of 5. Square root of 5 times 4 is 4 square root of 5. And square root of 5 times the square root of 5 is square root of 25. The denominator of 4 times 4 is 16. 4 times square root of 5 is 4 square root of 5, positive. Negative square root of 5 times 4 is a negative 4 square root of 5. And the negative square root of 5 times a positive square root of 5 is a square root of 25. After you multiply, you look to simplify. It's either gathering in like terms or simplifying the radicals. So looking at, we have like terms right here, and we can simplify the square root of 25. So square root of 25 is 5, so 5 plus 8 are like terms, that's 13. 2 square root of 5 plus 4 square root of 5 minus 5 is 11. And we look at 13, 6, and 11. All those coefficients or terms do not simplify. So that's your final answer. Alright, moving on to our last section here. So we need to solve. That's our goal here, solve for x. Get the x by itself. You need to isolate the radical first. So on the outside we have an addition and we have a multiplication. Reverse order of operations is you have to take care of the addition. Well, you're adding 1, 1's positive, so we subtract 1. And I believe that started out a plus, so yep, 3 root of 2x equals negative 15. This is multiplication here, so it's divide by 3. Cube root of 2x equals negative 5. Raise it to the opposite of cube root is cubed. Negative 5 cubed is negative 125. Divide by 2. We get x equals negative 125 over 2. Now we do need to check this. I ran out of room on the right, so let's check it over here. You check it with the original question. over 2 equals negative 14. Okay, so we have 1 plus 3 on the other side. Do not multiply or add those. You have to multiply before you add. Negative 125 over 2 times 2, those will simplify out, and you get cube root of negative 125. Cube root of negative 125 is negative 5. And 3 plus negative, or 3 times negative 5. So that checks out. So this is a good answer. Alright, otherwise it would be extraneous if it didn't work out. Next. So there's 2 things we can do here with it being raised to, both bases are raised to the 1/2 power. We could raise it to the square it and square it, and that will cancel. So 1/2, so power to power, those rules. 1/2 times 2 is 1. So that cancels it out essentially. Otherwise, a lot of you are going to switch that to 1/2. You're going to switch it to a square root, which usually we don't write the 2, but you can if you want, and then you would square it. Either way, doesn't matter how you do it. Not a whole lot of time difference, so really doesn't matter. But square roots and square cancel. And now we're gathering our like terms. So, and they're across the equal sign, so we need to, I'm going to put all my c's to one side and all my constant terms on the other. Divide by 4, and you get c equals negative 3. Now we substitute that back into the original problem, and so we have, so our check, and you should always check them. 8 minus negative 3 to the 1/2 equals negative 4 minus 5 times negative 3 to the 1/2. So 8 minus 3 is 11. 11 to the 1/2. Negative 5 times negative 3 is positive 15 plus, so that's plus negative 4 is 11, and that's 11 to the 1/2. Those equal each other, so that's good. That's our good answer. Alright, moving on to number 17. So your first goal is to isolate the radical. It's already isolated. There's no add, subtract, multiply, divide on the outside, so undo the radical, so square it. And quadratic, and there's no way it's going to simplify out to solve. So add 11x and add 30. I'm going to rearrange these terms, so then it's the a term first. It's a positive x squared plus 11x plus 30. So you're a, b, and c. So you could set this up for quadratic formula. You could set it up for times c, or you could graph it. 30. What 2 numbers multiply to 30? That'll add up to the b, the 11, and that's 5 and 6. So I have x squared, breaking up the middle term into 5x plus 6x. Gather, group your first 2 terms and your last 2 terms. Look for your greatest common factor of each group, and that's x. Greatest common factor of the second group is 6. What's left over when you divide out the greatest common factors? That's one of your factors, is x plus 5. Your other factor is on the outside. And set each factor and solve. So you have negative 5 and negative 6. We've got to check these now. And check is not part of the, like, checking your work. It's checking to actually see if they're real, if they're actual answers. So negative 30 minus 11 times negative 5. So I'm checking negative 5 right now. And negative 55, or positive 55, and so that's 25. Negative 5 square root of 25 is 5. That doesn't work, so that's no good. And And let's check -6. Well, you can already see that's not going to work, because anytime you take the square root of any number, it's always positive. So we have +6 plus -30 is 36. -6 does not equal +6. So that doesn't work either. Solutions available. So both those are extraneous. No solution. Oh, you see that? No solution. Moving on to the next problem. First, it's positive x minus 8 then, instead of a -8. -8, which when you multiply that out, x times x is x squared, minus 8x, minus 8x, and subtract. So I see a quadratic term, and there's no way that quadratic term is going to simplify out, so we got to gather and you can graph this, or again you formula, or you can graph it. So if we graph it, go to y equals, or Desmos. Desmos is going to be easy also. And on Desmos, when you go to graph, eight are your solutions. X equals 1, x equals 8. If you want to know more about the actual calculator and how to do that, I will. So square root of 56 minus 7 times 1 minus 1 equals -8. So we have 56 minus 7, or 7 times 1 is 7, so that's 49. And 1, well, nope, doesn't equal -8. So that doesn't work. And let's check this next one. I have a feeling this isn't going to work. And 56 minus 56 is 0. Keep going. Moving on to the back. If we choose, if you want to choose to do this on the test as your first opportunity. Graphing this, so we have, it's a square root function. So square root functions, the parent function starts at 0, 0, and 1, 1. I will make a little t-chart here. There's other points like 2, 4 you could also do, or 4, 2, my bad, 4, 2. Square root of 4 is 2, so 4, 2. You could do like 9, 3 also. But anyways, we're going to do dilation. So we're going to dilate. So we're supposed to move right 2 first and then dilate. Really doesn't matter. In the future, you're supposed to work order of operations. So you should subtract 2 first. So we're going to go to the right 2. So that would add 2 to your x values, and then multiply by 3 the y values. So after we dilate it, you're still going to have 0, 0, 1, 3, and 3 times 2 is 6. So 0, 0, 1, 3, and 4, 6. So these points and to the right 2 and up 6. So each point's got to go right 2 and up 6. 1, 2, 3, 4, 5, 6. And right 2, up 1, 2, 3, 4, 5, 6. And right 2, up 1, 2, 3, 4. Alright, next. Our points are 0, 0, negative 1, negative 1, and 1, 1. So dilation of 4, so we're going to take a multiply of the y values times 4. Zero, negative 4, positive 4. And we're going to move it left 1 and up 5. So 0, 0 is going to go left 1, up 5. Negative 1, negative 4 is going to go left 1 and up 5. And 1, 1 is going to go left 1 and up 5.